People talk about Australia like it's the definitive benchmark for dangerous wildlife. And fair enough, it holds that title in a lot of categories, but when it comes to reptiles that are chemically and mechanically sophisticated, North America's deserts have produced something genuinely worth talking about. The Sonoran, the Mojave, the Chihuahuan. Sub-zero nights, 60-degree days, months at a stretch without rain. The animals that made it here didn't just adapt to those conditions. They turned them into part of how they hunt, how they hide, and how they survive being hunted. 3 reptiles stand out: a pit viper, whose venom runs 2 separate attack systems at once, a slow-moving armored lizard that clamps down and chews until the job is done, and a small, spike-covered desert specialist with a defense mechanism so unusual that most people assume it's made up. None of them are extinct. They're all out there right now. Reptiles scutellatus, the Mojave rattlesnake. It has a strong case for being the most dangerous snake in the American Southwest, and that claim isn't based on size or reputation. It comes from the chemistry. Most adults run between 60 and 100 centimeters. The biggest specimens reach around 130, roughly the length of a golf club. It's not a large snake by North American standards. The size is almost beside the point. The Mojave rattlesnake carries 2 distinct venom phenotypes. Type A is a powerful neurotoxin built around a compound called Mojave toxin, a presynaptic phospholipase that interferes with neuromuscular transmission. Type B runs hemotoxic, breaking down blood and tissue and causing hemorrhage. Most rattlesnake populations carry one or the other. Some Mojave populations carry both. Mojave toxin is roughly 10 times more potent by weight than Western diamondback venom, which is already considered one of the most medically serious snake venoms on the continent. The LD50 data puts Mojave toxin near the top of the Western Hemisphere rankings. When type A venom reaches the neuromuscular junction, Mojave toxin degrades the presynaptic membrane and shuts down acetylcholine release. The signal from the nervous system to the muscles stops arriving. The diaphragm is a muscle. It stops moving. Without treatment, that's a respiratory arrest. Type B venom takes a different route. The hemotoxins break down red blood cells and erode the tissue-lining blood vessels. Clotting stops working, wounds stay open. Internal bleeding progresses with little visible evidence on the surface. The populations carrying both phenotypes are a genuine clinical problem. Physicians can't assume which venom is dominant based on symptoms alone, because the presentation overlaps and shifts. The treatment protocols for neurotoxic and hemotoxic and venomation differ enough that guessing wrong matters. On top of the chemistry, the Mojave rattlesnake is documented as more defensively aggressive than most North American pit vipers. It holds its ground and will strike multiple times rather than retreat. Its gray-green banded coloration matches the rocky scrubland of the Mojave so well that herpetologists routinely describe it as effectively invisible at rest. You're on top of it before you know it's there. 2 venoms targeting separate biological systems. Documented aggression. Desert camouflage that essentially removes it from view. The Mojave rattlesnake doesn't need to be large to be dangerous. Heloderma suspectum, the Gila monster. It's the largest lizard native to the United States, one of only 2 venomous lizard species in North America, and it has been here in roughly this form for approximately 98 million years. The Rocky Mountains are younger than this animal's lineage. Adults reach between 38 and 56 centimeters and weigh up to 2 kilograms. The body is heavy and armored with bead-like osteoderms. The coloration, black and orange or black and pink, is aposematic. It's not camouflage. The animal is advertising itself, and the advertisement has worked for nearly 100 million years. The venom system is where this animal gets genuinely unusual. Venom glands sit in the lower jaw, and the venom travels into the wound through grooves running between the teeth via capillary action. There's no dedicated fang, no single injection point. To get venom deep into tissue, the Gila monster clamps down and chews, working the jaw back and forth to drive more venom through the grooves with each movement. The venom contains serotonin, phospholipase A2, and a kallikrein-like enzyme. In combination, these cause severe localized pain, significant swelling, a rapid drop in blood pressure, and in serious cases, cardiovascular shock. Research published in Toxicon confirmed that blood pressure can fall substantially within minutes of a bite. The jaw muscles are dense, and the skull is reinforced to sustain prolonged clamping. Documented encounters show Gila monsters holding their grip for up to 15 minutes, pulling the animal off forcibly, tears more tissue, and drives the teeth deeper into the wound. The clinically accepted removal method is water immersion near the jaw, or in the field, a flame. In 2005, the FDA-approved Exentide, a synthetic compound based on exendin-4, a protein found in Gila monster saliva, as a treatment for type 2 diabetes. It's marketed as Byetta and remains in clinical use. The same animal that requires a flame to remove from a bite wound provided the molecular basis for a drug taken by millions of people. It's a strange thing to hold in your head at the same time. An animal that's medically dangerous on one side of the ledger and medically invaluable on the other. Evolution doesn't make those distinctions. It just keeps selecting for what works. A Cretaceous-era armored lizard. A bite that holds for a quarter of an hour. A chewing venom system found nowhere else on Earth. And somewhere in the history of studying it, a diabetes drug. The Gila monster is one of the stranger animals this continent has produced, and it's been producing it for nearly 100 million years. Rhinosoma cornutum, the Texas horned lizard. People call it a horny toad, which tells you something about how it looks, but nothing accurate about what it is. It's a lizard, fully reptilian, and it has been living in the arid grasslands of the central Southwest for a very long time. Most adults are between 7 and 15 centimeters, small enough to sit in your palm. The body is flat and wide, ringed with a crown of occipital spines projecting backward and outward, plus several rows of smaller lateral spines along the sides. The overall shape looks like something a child drew when asked to design an intimidating lizard. The spines are the first line of defense, and they work mechanically. When a hawk or coyote tries to swallow a horned lizard, the spine array catches in the predator's throat and creates enough obstruction to make swallowing impossible. There are recorded instances of predators regurgitating horned lizards alive. The lizard walks away from the attempt intact. The spines are remarkable. They are also the second most unusual thing about this animal. When the spines aren't enough, the Texas horned lizard constricts the blood vessels, carrying blood away from its head. Pressure builds in the ocular sinuses, the blood-filled chambers behind the eyes. When the pressure reaches a critical point, small vessels at the eyelid margin rupture, and the lizard projects a jet of blood outward from the eye. The range is up to 150 centimeters, around 5 feet. The blood is chemically aversive to canids. The Texas horned lizard's primary diet is harvester ants, and compounds from those ants accumulate in the bloodstream. To coyotes, wolves, and dogs, the blood tastes strongly repellent. The lizard has, over evolutionary time, built a chemical deterrent out of its own food supply and learned to fire it through its eye socket. Research has confirmed the lizard can fire from either eye independently or both at once, and can repeat the defense multiple times. The blood volume expelled in a single event can represent up to a third of the animal's total blood. It is not a cheap response, and it uses it anyway. The irony is that the Texas horned lizard is now one of the more threatened reptiles in North America. The main driver is the spread of the red imported fire ant across the historic range. Harvester ants, the horned lizard's primary food source, get displaced as fire ants move in. The horned lizard cannot digest fire ants effectively, and when the harvester ants go, the lizard follows. An animal that survived here for millions of years, defended against hawks, coyotes, and wolves by shooting foul-tasting blood from its eyes, is losing ground to an introduced insect. That's where things stand. Thanks for watching, and until next time on Specimen.